Hello friends. So today we are going to start new topic, center of mass. So before going to center of mass, I have one question, that if I will take one particle and we are throwing at certain angle theta, how will be its trajectory? So its trajectory will look like almost in this way. It will go in a parabolic path. So to study about the trajectory equation is easy. To write the equation of this trajectory is easy. It's not difficult. But the same time, if I will take any extended body, for example this pen, and I will throw this pen at certain angle theta. So how will be its trajectory? So its trajectory, you will see here, it will look like this. It will spin, rotate and translate in this way. So here the different points of this extended bodies are going in different paths. For example, here if I will focus on this point, so how is it going? It's going almost like this. So really it's a very complicated path. In the same way, different points are going in different way. So to write the equation of trajectory for this whole body, it's very complicated. So how to write the equation of trajectory for this whole body? So for that, if you will focus, you will find one red dot, and that red dot is going in a parabolic path. So what is this red dot? We will understand this here. So for example, if you will take one uniform scale, correct? And the length of this uniform scale is L. Now, let us consider the mass of this uniform scale is 5 kg, correct? Now, what I will do, I will take one point at the center of this uniform scale, and I will consider that whole mass is to be concentrated at this point. It means this 5 kg is what? Uniformly distributed on a scale. But what will I consider? That whole mass of this scale, that is 5 kg, is concentrated at this point only. Now you will ask, what will happen if I will concentrate? How will be it helpful if I will concentrate here? So we'll see here. See here, it will be helpful. So if I will apply one force F equals to 5 Newton at this point, and I concentrated already at this point the whole mass 5 kg, at this point only, and I want to find its motion, it means its acceleration, then how will I find? By the Newton's second law of motion, we can say that A equals to net external force, that is what? 5 Newton divided by the total mass is to be concentrated here, that is what? 5 kg. It can be written as 1 meter per second square. So now, is this 1 meter per second square only acceleration of this point? No. This 1 meter per second square is the acceleration of whole body. So see here what I have done. I just concentrated the whole mass at this point, and when I am applying the force here at this point and I find it the acceleration, that acceleration is not only the acceleration of this point, this acceleration is the acceleration of whole body. So here, by concentrating whole mass at this point, I can easily find the acceleration of the whole body. And this point is known to be as what? Center of mass. So we can define as a center of mass as this is the point of a body where whole mass of a system is to be concentrated. And by concentrating the whole mass, what will happen? We can use all the equations that we have studied for motion on that point only, and by doing that, whatever the result we will get, that result will be applicable for whole body. It means that that point is representing the whole body. Now, till now you studied Newton's laws of motion. In that already we took different forces were acting on the body and we are finding the acceleration. So at that time we were assuming that whole mass was on the center of mass, and that force was acting at the center of mass only. And then only we are able to find the acceleration, and that acceleration was not the acceleration of that point, it was acceleration of whole body. Now next question will be there, if the force is not acting at the point. For example, here I consider that this force is acting at this point only, where I concentrated the whole mass. But if this force is not acting at this point, it will act at different point, then what will happen? So here, if this will happen, for example, if I will take a scale, okay, and here, if this force F5 Newton is acting, and the whole mass I concentrated here, it means this is center of mass. So what will happen in this case? In this case, because this force is not acting at center of mass, this whole body is start to rotate about the center of mass. Means what? In the case when I will consider the force is not acting at the center of mass, it's another point than center of mass. In that case, that whole body will start to rotate about the center of mass. So if you have one body, for example, any extended body is there, and you want to find its center of mass, so how can you do it? You will just apply the force at any point, and this whole body will start to rotate, and the point about which it will start to rotate, you just consider that is the center of mass, this whole body. Okay. Now here you can see here, when I'm just projecting one extended body in this way, then this extended body is rotating like this. So here you can observe that this whole body is rotating about this dot point, this red dot point. So this red dot point is nothing but the center of mass. Okay. Now here we can say that center of mass of a system is a point where the whole mass of the system is to be concentrated as it is. That we have studied now only, just I have written that center of mass of a system is a point where the whole mass of the system is to be concentrated. Now next point is that center of mass can be inside or outside of the body. It doesn't mean that center of mass will be always inside the body. For example, in case you have seen that scale I took, in that case the center of mass was on the center, so it was on body. But if this type of a structure is there, okay, this type of a structure is there, okay, so here in this, if I will say that where the center of mass, so it will be here, okay, and here it is hollow, so here the center of mass is not on the body, it's outside the body. So center of mass may be inside the body and may be outside the body. Okay. Now next is independent of the state of the body. It doesn't matter that body is in rest or motion. Center of mass, if we find it, that center of mass is not going to change. If we are not changing the mass or mass distribution, then definitely center of mass is not going to change. Either body is in rest or motion, doesn't matter. Okay. Now next, represents the motion of a body. It represents the motion of body, as I discussed now only, that whole body is there. Okay. So I'm not taking different points of the body. I just concentrated the whole mass at that point, and about that point, whatever the motion is happening, I am just considering all the forces acting at that point only, and whatever the acceleration I find it, that is representing the acceleration of whole body, not only that point. Clear? The next one is, if body is free to rotate, it will rotate about its center of mass. That's I told you that, for example, this pen is here and I am applying the force other than the center of mass, then what will happen? It will start, if it is free to rotate, for example, it is not fixed anywhere, then definitely it will rotate about its center of mass. Okay. Now see here, how the center of mass is changing. For example, if I will take two particles, okay, if I will take two particles, the particle M1 and the particle M2, okay, now the center of mass will be lies somewhere between them. Okay, so for example, if M2 is greater than M1, So center of mass will lie near to what? M2. Okay. Now if I will add any third point mass here, M3, correct? Now here, if I will join these two lines, because M1 and M2 center of mass was here, now I added another mass M3 in this system, then definitely center of mass will lie somewhere between these 2 points. So for example, maybe it will lie here. Okay. So center of mass can be shifted if you will add or remove mass from the whole system. Is it clear? In the same way, for example, if you have one body like this, for example, this is what rectangular plate, and if it is a uniform, then definitely the center of mass will lie on its physical center. Same way, if you will take one circular plate, then its center of mass will lie its physical center. So just keep it in mind. If it is a uniform body, uniform means what? Mass is uniformly distributed everywhere, then center of mass will lie on its physical center only. Okay. If it's a uniform body like as a square plate, circular plate, then definitely center of mass will lie on its physical center. But if it is a not uniform body, then its center of mass will not lie on the physical center. For example, I have one plate, okay, like this, and another plate in this way. Okay. Now here one plate having mass M1 and another plate having mass M2, and M1, M2 is not equal, correct? So its center of mass will not lie on this line. Definitely it will not lie. Why? Because M1 and M2 is not same. Here, if I will consider M2 is greater than M1. Okay. So for example, M2 mass square plate is uniform. Separately it is uniform. So its center of mass will lie on its physical center. And M1 separately is uniform. Then its center of mass will lie on this center, physical center. Okay. So this is center of mass 1 for M1 and this is center of mass for M2. But if both are in one system, so their center of mass, because if I will consider M2 is greater than M1, so their center of mass will lie somewhere near to what? Inside what? Inside the M2 plate. Okay. So near to center of mass of what? M2 plate. So here the center of mass of the whole system will lie. Clear? Now, what is the exact position of the center of mass? Next question. We just understood that how to take the center of mass. Okay. What is the center of mass? The basic definition till now we are knowing. But how to find the center of mass? What is the way to find the center of mass? We will study now. Okay. Now, here only, if we want to find the exact position of the center of mass, then what we'll do? Let's see. So before going to understand that how to find the center of mass, we should understand the mass moment concept. Okay. So mass moment. Concept is mass moment. Mass moment. So what is the mass moment? So mass moment can be defined as, for example, any particle is here, point P. If the position vector of the particle, let the particle at point P having mass m, and the position vector of this particle is r vector. Okay. So the mass moment of this particle is defined as, mass moment of this particle that is at point P is defined as mr vector. Mr vector, where m is the mass of the particle and r vector is what? Position vector. Okay. Now, how it will be useful to find the center of mass? We'll see here. For example, if you have one system of particle, in that different particles are there, m1, m2, m3, and their position vectors are given, r1 vector, R2 vector and R3 vector, correct? Now let us see here if M1, M2 and M3 is what? One system. Let us consider this is one system and the center of mass is somewhere here. I just consider that the center of mass is here and its position vector will be RC vector. Its position vector will be RC vector. This is what? Center of mass of this three particle system. Okay. Now here if I will consider center of mass as a reference point for this whole system. Okay. So here if I will find this one as a RC1 vector, okay, this one as a RC2 vector and this one as a RC3 vector, correct? Okay. So how can I write RC1 vector in terms of RC vector and R1 vector? So we will use the triangle law of vector addition. So according to triangle law of vector addition, you can see this is RC vector plus RC1 vector equals to R1 vector. We can write what? Triangle of vector addition, we can use RC vector, correct, plus RC1 vector equals to what? R1 vector, equals to R1 vector. Okay. Now I have to find what? RC1 vector. Okay. So what is the RC1 vector? RC1 vector is what? R1 vector minus what? RC vector, correct? Similarly, we can write RC2 vector. What is the RC2 vector? RC2 vector. What can I say? RC2 vector. Same way, R2 vector minus RC vector, correct? Same way, RC3 vector if I want to write. RC3 vector. So it can be written as what? R3 vector minus RC vector, correct? Now, what will I do? Here one concept is here. If in a system of particle, if you consider center of mass as a reference and you will find different particle mass moment with respect to center of mass, then sum of the mass moment of all the particle equals to 0. Did you understand? I will repeat it again. If in a system of particle, at the center of mass, if you will consider it is a reference point, and by considering the center of mass as a reference point, you will find the mass moment of each particle, and then you will add all those mass moment, that means sum of all those mass moment, then that will be equals to 0, correct? So here, if I will consider this center of mass as a reference, what will be the mass moment of M1, M2 and M3? As I discussed now only, that mass moment is a product of what? Mass and the position vector. So with respect to center of mass, what is the position vector of this point M1? RC1 vector. What is the position vector of M2? RC2 vector. What is the position vector of M3? RC3 vector. So we will write the mass moment of individual and we will add it and we will equate equals to 0. So we will do it. So here we can write this one. So we will write this one. Here we will do it. M1 into RC1 vector. What is the RC1 vector? R1 vector minus RC vector, correct? Plus what? M2 into RC2 vector. So RC2 vector we can write what? RC2 vector we will write R2 vector minus RC vector, correct? Plus M3 into R3 vector minus RC vector. And I took all mass moment, sum of the all mass moment, and then we will equate equals to 0. We will equate equals to 0. Then what we will find? We will solve this. We will get what? RC vector equals to M1 R1 vector. RC vector equals to, here we will get it, RC vector equals to, when you will solve this, you will get RC vector equals to what? M1 R1 vector, M1 R1 vector plus M2 R2 vector plus M3 R3 vector divided by M1 plus M2 plus M3. So this is what? This is what? RC vector that what we have to find, RC vector we wanted to find, we got the position vector of what? Center of mass by doing this. Same way we can write, here we find it RC vector, same way we can find XC vector. What will be the XC vector? Tell me. XC vector will be what? M1 R1 vector. So here we can write what? M1 what? X1 vector plus M2 X2 vector plus M3 X3 vector divided by M1 plus M2 plus M3. Correct? Same way, if you will write YC vectors, what is the YC vector? YC vector will be M1 Y1 vector plus M2 Y2 vector plus M3 Y3 vector divided by M1 plus M2 plus M3. So in this way, we can find different particle system, center of mass, position vectors. Okay. So we have finded XC vector, YC vector and what? RC vector. Correct. So we will see one problem based on this concept. Okay. So here one question is there. Three masses are positions on the x-axis. A 300 gram mass at the origin, a 500 gram mass at x equals to 40 centimeter and a 400 gram mass at x equals to 70 centimeter. The distance of the center of mass from the origin is. So we will draw this first. So here every particle is on the x-axis only. Okay. So here three masses and the first particle, the 300 gram is origin. So we will consider here origin. Okay. So at origin which mass is there? 300 gram. So here 300 gram we will consider here. Now next particle 500 gram at x equals to 40 centimeter. Correct. So here at x equals to 40 centimeter we will consider the 400 gram mass. What? 400 gram mass. Correct. Next is at what? X equals to 70 centimeter. X equals to 70 centimeter. How much mass it is? It is here it is 500 gram and here it is 500 gram and at this point it is 400 gram. At x equals to 70 centimeter it is what? 400 gram. Now just we have studied that how to find the center of mass position, because here only x coordinate, all the particles along the x coordinate only. So center of mass will be definitely lie on along what? X coordinate only. So what is the x center of mass? Just we find it. So according to that, M1 x1 plus M2 x2 plus M3 x3. So already positions are given. So very easy. 300 into 0, 300 into 0 plus 500 into 40, 500 into 40 plus 400 into 70, 400 into 70. Here no need to change the unit also because it will cancel out. So here sum of all the masses we find it. So M1 plus M2 plus M3, 300 plus 500, 300 plus 500 plus 400. Correct. Now finally what will you get? You will get, this is totally 0, 500 into 40 plus 400 into 70. So here it is, you can take common 100, 1000 you can take common. So it is 1000 you will take common into 5 into 4, 20 plus what? 4 into 7, 28. Okay, divided by what? 400 plus 500, 900, 900 plus 300, it is how much? 1200. 1200. Okay, this 0 cancel out. Okay, so we can write this is 5 by 6. So here it will be 5 by 6 into what? 48, 8 times 8 into 5 is what? 40 centimeter. So we will get the answer what? 40 centimeters. So option A is correct. I think so you understood this. Just I use the basic concepts here and I find it what? X center of mass. Okay. Now we'll go for next question. Here you can see question is 3-point particles of masses 1 kg of masses 1 kg, 1.5 kg, 2.5 kg are placed at the three corners of a right angle triangle. Of side 4 centimeter as shown in the figure, at side 4 centimeter, what 3 centimeter and 5 centimeter as shown in the figure. The center of the mass of the system, the center of the mass of a system is at point. You have to find the center of mass. Okay. Now see here how to find. Whenever this type of question is there, you should take that whole system, you try to take whole system on a what? Coordinate system. So here what I will draw the coordinate of this. Let consider here x coordinate I will take, and here what? Y coordinate I will take. Okay. So this particle 1.5 kg will come at what? Here if I will take origin, 1 kg at origin. Okay. Now 3 centimeter distance. This means what? This means what? This 1.5 kg in x direction is 3 centimeter. So we can write this is a 3 in x and it is along the x axis. So at this point y is 0. So 3 comma 0 we can take. Correct? We can take at this point is what? 3 comma 0. Same way 2.5 kg on the y axis at 4 centimeter. So x is 0 here, but y is what? 4 centimeter. Correct? 0 comma 4 we can do. Okay. Now we have to find what? We have to find the center of mass position. So here x particle is in x also, y also. So its 2 coordinate will come, center of mass 2 coordinate will come, x center of mass will also come and y center of mass will also come. So we'll find both. Okay. So first we'll find x center of mass. So what is the x center of mass? X center of mass. So formula is what? M1 x1 plus M2 x2 plus M3 x3. So see here, simply you can say M1 x1, that means 1 into 0 will be 0. Here 2.5 into 0 will be 0. Only you can write here 1.5 into 3. This is what? 1.5, 4.5 it will be. 1.5 into 3, it is what? 4.5. Okay. Divided by total mass. Always you have to do total mass. 1 plus 2.5, 3.5. 3.5, this is what? 4 plus 1, 6. It is what? 6. Okay. So it is what? 4.5 divided by 6. Correct only? Once you check the calculation. It is what? 2.5 plus 1.5, that's 3, 1, 4, 4, 1, 5. Sorry, it is 5. It is what? 5. It is 5. Okay. So if it is 5, then it is what? 0.9 centimeter. Correct? 0.9 centimeter. We have no need to change in unit because the answer is in centimeter only. Options are in centimeter only. So 0.9 centimeter. So x coordinate is in what? X coordinate of the center of mass is what? 0.9 centimeter. So see here, x coordinate we are getting 0.9 centimeter. We have to find y coordinate. So now y coordinate of the center of mass. Same way m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. So here you see, here 0, y is 0 here. Okay. Here y is 0. So this no need to take, only here 2.5 into 4. 2.5 into 4 divided by what? Total mass, that is what? 5. So 2.5 divided by this is 2. This is what? 2 centimeter. 2 centimeter. So here by saying this you can say what? Y axis it is 2 centimeter. So 2 centimeter above what? It is what? 1 kg and 0.9 centimeter right of what? 1 kg. Okay. So the option B is the correct option. Okay. 0.9 centimeter right and 2 centimeter above the 1 kg, because above means what? Y axis, y coordinate of center of mass, and right is what? Right is how much? It is x coordinate center of mass. That is how much? 0.9 centimeter. So y coordinate it is what? 2 centimeter. That's why 2 centimeter above the 1 kg and 0.9 centimeter right to 1 kg. Okay. So we'll go for next question now. Now you see this figure. Here figure shows a coordinate system which 8 uniform cubes of side A are placed as shown here. This system you can see. In this system here, how many cubes are there? 8 cubes are there. Okay. Now if masses of cubes 1, 2, 3, 4, 1, 2, 3, 4, these masses are given what? M. So this is what? This is M, this is M, this is M, this is M. Okay, 1, 2, 3, 4 is what? Each mass is M. And 2M for remaining means what? This is 2M, this is 2M, this is 2M, and this is also 2M. Correct? Now find the location of the center of mass of the system. So how to find the center of mass of the system? So in this type of question, we will find x center of mass separately, y center of mass separately. And because this is what uniform cubes, and as I discussed already, for a uniform distribution of mass, the center of mass will lie on its physical center, correct? So here also it will be like that only. So now for x center of mass, so see here, for example, I will divide in system wise. This is one, this is another, first system, second system, third system, fourth system. This means what? This means what? One system representing one total mass. For example, 2m plus 2m plus m. That is what 5m. So 5m is one system. So first I will find 5m where position of the 5m. Okay. So 5m position will be its own center of mass. Okay. 2m plus m, 3m will be it whole mass. I will concentrate only for this center of mass. Same with 2m plus m, 3m. Total mass 3m will I consider on the center of mass this along the x-axis. Same way m is at the center of mass of this cube, and their position I will take from what? Origin. So origin is what? 0, 0. So see here, if I will consider 2m, 2m and 2m, this is what? 2m, 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 5m. So from origin, because this side is A, this side is A, so because this is uniform, so from the origin, it will be what position? So here, because it will be center and physical center will be A by 2. So from origin it will be what? A by 2. So we can consider this is what? 5m at what position? A by 2. This position is what? A by 2. Correct? Okay. Now same way 2m plus m, 3m. 3m also from here A by 2. So from here what? A plus A by 2. From here what? A plus A by 2. Same way this is 2m plus m. This is what? 3m. 3m will be here. So 3m will be from here A by 2. So from here what? A plus A, 2a, 2a plus A by 2. Similarly, m will be at its center, physical center. So this is A by 2. So it will be where? 3a plus A by 2. Okay. So like this we defined each system on its center of mass and different points. Different coordinates are defined. Same way y direction also we will do. So we will write first this one. Okay. So here for x coordinate, for example, I am doing for the x coordinate. Okay. So here for x coordinate, x center of mass, if I am writing x center of mass, I am writing. Okay. So x coordinate I will go. So here first 5m is at what? A by 2 distance from the what? Origin along the x-axis. So I will write it is what? 5m, because total 5m represented at what? X center of mass of this 5m. So this 5m will be where? A by 2 distance, because this is uniform. Okay. So A by 2 distance from the origin, A by 2. So 5m into A by 2. Correct. Now I will see next one, 2m plus m. This is what? 3m. So 3m from here A by 2, but from here A plus A by 2 means we can write it as a 3m A plus A by 2. From here A plus A by 2. This is how much? It is 3a by 2 into 3a by 2. 3a by 2. Correct. Next plus what? 2m plus m, 3m. This is what? 2a plus a by 2. This is what? 5a by 2. So 2m plus m, 3m, again it is what? 3m. Okay. 3m into what? 5a by 2. How 5a by 2? From origin, you always take from origin. What is the position of center of mass? This system from the origin. So a plus a, 2a plus a by 2. That is what? 5a by 2. Okay. Now next is m. So plus here you will write in this way. Here this is x center of mass. So remaining plus m into what? 3a plus a by 2. This is what? 7a by 2. 7a by 2 divided by total mass. Total mass is what? 5m plus 3m, 8m, 8m plus m, 9m, 9m plus 3m. How much? 12m. 12m. You will solve this, you will get the x center of mass. Same way, y center of mass you have to find. Y center of mass. Correct? So see here, y center of mass we will go along the y-axis. So along the y-axis when we are going, this is m. This is 4m. Okay. So one system 4m, another system what? 6m. Then another system is what? 2m. So 4m, from here it will be a by 2, physical center a by 2, because it is uniform. So we will write 4m. From the origin it is 4m into what? A by 2 along y-axis, plus what? Next is what? 6m. 6m 6m, okay, 6m at what? A plus A by 2. This is what? A plus A by 2. That is what? 3A by 2. 3A by 2. Correct? Next one is 2m. 2m is what? Its physical center. That is A by 2 from here. From here is what? 2A plus A by 2. So, plus what? 2m into what? 2A plus A by 2. This is what? 5A by 2. 5A by 2 divided by what? 12m. You will solve this, you will get y center of mass, and that is asking find the location of the center of mass of the system. That is what? X center of mass and y center of mass. So we'll go for next problem. Now you see here, it's given one letter E, and one plate is here, uniform plate is there of shape E as shown. Find the coordinate of the center of mass of this system, this structure. Now just try to understand, whenever in a laminar type of body, means two-dimensional body is there, two-dimensional plate is there. So that time if mass is not given, then what should we consider? We should consider, because if it is a uniform, mass is uniformly distributed on its area. So mass is proportional to area only. We will take. What we will take? Mass is proportional to area, because mass is uniformly distributed over its area. Okay. As same way, for example, if mass is distributed over its volume, so mass will be directly proportional to volume. If it is a uniformly distributed, correct? So here I will divide this whole plate, okay, in different part. Okay, so we can do it in this way. For example, here one part, this one, okay, and I can do it in this way, one part in this way, okay, just like this I have done. Okay, so how many part? 1, 2, 3, 4, 5. It depends on you. You can divide in different way, okay, and you can find a center of mass separately, and then you will find X center of mass and Y center of mass. Okay, so see here, first part, what is the area of this? A into 3A square. So here mass is, you should understand that mass is laminar body, two-dimensional body, and uniformly distributed mass over the area. So mass is proportional to area, correct? So mass is proportional to area. So first we will find the M1 mass. What is M1 mass is proportional to area? So I can write this is what? 3A into A, 3A square. Same way M2. What is the M2? I can write A into this length is also A. This is what? 2A. Okay, so this is 2A. And this length is what? A. So A into A, this is what? A square. Correct? What is the M3? M3 is what? A into this one. This is 2A. So 2A into A, that is what? A into 2A. A into 2A. This is what? 2A square. Just try to understand how I am taking the length. Okay. Now see here. This length is 2A. Correct? This is A. This is also A. So total is what? 3A. A plus A plus A. 3A. Correct? Okay. So here when I am finding the mass of third part, so this is what? A plus A, this is 2A and this is A. So 2A into A is what? 2A into A is what? 2A square. Same way M4 is what? A into A, that is what? A square. And then M5, what is the M5? A into 3A, this is what? 3A square. Same way like this. M1 and M5 is what? Same only, correct? Now here I have to find what? X center of mass and Y center of mass. Now you see here. Here when you will take your hand in this way, now you can see I just put on the Y axis, okay, and up and down you see it is looking symmetrical or not? Up and down is from half, it is symmetrical up and down, correct? So it means what? Along the Y axis it is what? Mass is uniformly distributed, symmetrical. Okay, so whenever uniform distribution mass is there, as I told you already, that mass will be on the physical center. But here only along the Y it is uniformly distributed, not along the X. So along the Y it will be what? On physical center. So what is the length along the Y? 5A. So its physical center will be what? 5A by 2. So we no need to find Y center of mass. We can directly write Y center of mass will be 5A by 2. But along X when you keep hand, right and left are not same. In the middle if you will keep right and left are not same, it means mass is not symmetrically distributed along X axis. It means the x center of mass, you cannot write 3a by 2. You have to find it. Okay, so we'll find the x center of mass. So what is the x center of mass here? X center of mass. X center of mass here. X center of mass. Okay, so x center of mass will be m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 plus m5 x5 divided by sum of all masses. So what is the x1 x2 x3 x4? So see here, because this is uniform body, individually if I will take it is uniform body only, so here its center of mass will be on its physical center, and because from here it is 3a, so x it is what? 3a by 2. 3a by 2 for only for one part 1, 3a by 2. Same way I can write for others. X1 it is what? 3a by 2. What is the x2? X2 you see here, it is from here it is a length, so its physical center along x is what? A by 2. So x2 is what? A by 2. Same way x3. X3 is what? Here it is from here along x, how much length it is? It is a plus a, 2a. So 2a by 2 it is what? A. 2a by 2 it is what? A only. Same way x4, see here, x4 same way it is a, so its physical center from here you will see from y axis it is what? Along x, a length, so its center will be at a by 2 along x axis from this. Okay, so it will be a by 2, x coordinate of fourth part. Similarly x5, x5 it is like as what? 1 only. This is how much? 3a by 2. 3a by 2. Now what you have to do? You have to write simple equation m1 x1 plus m2 x2 plus so on till m3 m5 x5 divided by m1 plus m2 plus m3 so on till m5. You will add it, and after putting the value you will get the answer. So m1 is what? 3a square. See here, 3a square into x1 value is what? 3a by 2. 3a by 2, correct, plus m2 x2. m2 is how much? A square into a by 2. A square into a by 2 plus, okay, what next? m3, 2a square into a, 2a square into a, that is what? 2aq plus what next? m4, a square into x4. This is how much? aq by 4, correct? Am I correct here? A by 4, why I have written x4? We have to check. X4 is this one, na? Okay, so x4 is what? A by 2 only, na? It is a by 2. It is a by 2. Okay, a by 2, because from the y-axis this is how much length? A, so a by 2. So it is m4, a square into a by 2. A square into a by 2. A square into a by 2, correct? Then plus m5. See here, m5 is 3a square into 3a by 2. 3a square into 3a by 2. Here we can write 3a square into a by 2. Okay, 3a square into a by 2, correct, divided by, I will add all 3a square plus 2a square plus a square plus 3a square. This is how much? 3 plus a square is what? 4. 4 plus 2, 6. 6, 1, 7, 7, 3, 10. So 10a square. 10a square. Okay, just go through the calculation. 3, 4, 2, 6, 6, 7, 7, 3, 10. Yeah, 10a square. Now you just a square cancelled out. A square, a square, a square. Okay, now here a will remain a. Okay, a square, and then you add it, you will get the final x center of mass position. Okay, so like this you will get the final answer for x center of mass as well as y center of mass. Already we find it 5a by 2. So in this way we can find the center of mass position in the case of what? Discrete particle systems. Okay, so continuous bodies, for the continuous bodies we will discuss in next class. So don't miss the next class. So first class we have just discussed the basic concept of the center of mass. We will meet again in the next class. Thank you so much.